All right, this is the remainder of the section 3.5 notes that we had in class before our review on Tuesday. So we're going to look at a couple more of these graphing transformations and then some descriptions. And that's all we had left for that. So for this first one, we have that f of x equals the negative square root of x, and that's going to have the parent function just y equals the square root of x, because remember that is one of our shapes. And first thing you usually want to do is get a little graph for your parent function so you know what your transformation is going to build off of. With square roots, you can't plug in anything that's going to make it imaginary, so this would have to start at 0, and we're going to pick some perfect squares. So 0 square root is 0, square root of 1 is 1, square root of 4 is 2. So we're at 0, 0, 1, 1, and 4, 2. This is the parent function. Now the transformation that we're given has a negative in front of that. Now what we learned in class was that when there is a minus sign in front of the parent function, that is going to be a reflection over the x-axis. And what that means is that your y values are going to change signs. If they're positive, they'll go negative. If they're negative, they'll go positive. So for that, that means that our XY chart now, the X's are still going to stay the same, but the Y's are going to change signs. Now you can't change the sign of 0 because it is a neutral number, but we can change the other two. So this is going to be 0, 0, 1, negative 1, and 4, negative 2. So what you notice is it's the same as our parent function, but just flipped over the x-axis. Now, same idea here. I'm not going to redo the parent since it's also going to apply to this one. This also has the same parent, but this time the negative is inside. When the negative is inside, it's going to affect x. So this is actually going to be a reflection over the y-axis. So that means that our x is changing signs. And what we talked about in class was that anytime something happens inside the parent function, it's happening to x. Anytime something happens outside, it's happening to y. So remember, those are good general rules to remember. So the x's are going to change signs from the original parent, but the parent's y's are going to stay the same. So 0, 0, negative 1, 1, and negative 4, 2. So notice this one is the same as the original parent, but flipped across the y-axis. Okay, we had a couple more graphs that I wanted to do. Actually, no, that was all of the graphs. Nope, there's one more. I was supposed to say, I thought there was one more. So this one is the parent function would be x cubed, which we can get a chart for that real quick if we want. And since it's not a square root, I can pick anything I want. So I'll probably pick numbers though that are small because I'm going to be cubing them. So negative 2 cubed is negative 8, negative 1 cubed is negative 1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 1, 0, 0, 1, 1, and 2, 3, 4, 5, 6, 7, 8. Sorry, I have to count. So remember, we know that this guy is positive when you are positive x's. The y values are negative when there are negative x's plugged in because we're cubing. So we have a couple transformations happening here. First one to note is this multiplication. This is happening closest to our x, so in order of operation mode, this would come first. This is not inside the function though, because the x cubed does not have a parentheses around it. So this is going to be what we call a vertical change because it's happening outside of the function. So it's affecting y. And anytime it affects y, you do exactly what you see. So this is actually going to be making it smaller, which we call a compression. So we're going to take half of our y values to get this part. I'm going to use red to indicate my second transformation, which is this -2 after the function. Again, it's going to affect y because it's happening after the function. And when it happens afterwards, it's either a vertical shift up or down, and this one's minus, so this is going to be a vertical shift down 2. So that means our y values -2. Okay. All right, so let's do our blue. This is going to be our first. So we're going to do a half, we're going to do a drawing in the middle, and then our answer will be read over here. So that's for each of our transformations. So I want to take half of all my y values. So I'm going to keep my x values exactly the same, but I'm taking half of my y values. Half of 0 is still 0. Okay, so we're going to plot, and I'm going to plot this right here, sorry. So -2, -4, -1, -1/2, 0, 0, 1/2, 2, 4. So notice it's reaching those heights at, slower than it was before. Okay, and then we have to do the -2. So I'm going to make a little chart here for that. So all of our y values are going to subtract 2 from them. So that's going to be -4 minus 2 would be -6. -1/2 minus 2 will be -2.5. 0 minus 2 for the y value is going to be -2. 1/2 minus 2 is going to be -1.5. And 4 minus 2 is going to be 2. So let's plot these. So -2, -6, -1, -2.5, 0, -2, 1, -1.5, and 2, 2. So my graph was compressed to half its original vertical stretch, essentially, or vertical spread. It was also shifted down 2. Okay, so all that was left in section 3.5 is we needed to write descriptions of a couple of these transformations down here. So this one has I'm just going to make notes first, then we'll write our description. This one has a horizontal shift because we have a plus or minus inside the parentheses, and you always do opposite of what you see. So even though plus makes us think to the right, you're actually going to be reversing it. So it'd be left 4. That happens when it's inside the function. We also have the reflection over the x-axis. So if we want to write that as a nice sentence, we would say that y is the function f of x. And I'm saying f of x because they gave me the symbol f in my problem. If it was a g there, I would say g of x. And we want to go by order of operations. So we're going to say horizontally, or you could just say shifted left to the left 4, and reflected over the x-axis. Okay, for our last one down here, we have a 1/2 inside the parentheses. Now remember, when something happens inside the parentheses, we kind of do the opposite operation, and it's always horizontally affecting. So this is going to be a horizontal, and we normally would say a half is a compression, but because it's going to really be multiplying by 2, because we do the opposite because it's inside, it's going to end up being a horizontal stretch by a factor of 2, because that's the reciprocal. And there's also a vertical shift down 3. So we would say y is the function f of x. So if that was like a square root symbol there, I'd say y is the function f of x equals the square root of x. Horizontally stretched by a factor of 2 and shifted down 3. You can use vertically shifted if you want, but down is a vertical direction. So, all right, that is the end. So I'm going to save this file, and I will make sure that I post that with the video. And then I still have to do, and I'm about to do the part 3.6 video for you guys. So those are all going to be on the same playlist together. And I'll put an announcement once they're complete, making sure that you remember to watch everything before Tuesday's class. All right, thank you.